Welcome to another episode of the AI in Manufacturing podcast here on Industry4.tv. I'm your host, Kudzai Manditereza. In today's episode, we will discuss the future control platform, the unified namespace, and AI-driven optimization in the process industries. My guest on this episode is Zhang, who is the VP at Subcon and the founder of FreezoneX. Messi, welcome to the show. It's a great pleasure to have you on here today.
Thank you, Kudzai. It's an honor to be here.
Awesome. So, could you please begin by introducing yourself to the audience and also tell us more about Subcon and FreezoneX?
Yes, absolutely. So I will start from the company. Our company name is Subcon. It's quite a small name in the international landscape for now, but we're actually already 30 years old. We've been doing control system in process industry, that is DCS, for more than 30 years till now. So we used to be a school-oriented, like a school-originated company. So our founder, he used to be a professor of Zhejiang University. So yeah, like within SUPCON, you see most of the people and the managements are all from the same university. They're engineers, and some of them are the student of my founder. Same thing. I'm also the student of my founder. So it's quite a engineer culture organization. And apart from DCS, recent years, where our main topic or our main focus is doing basically software-driven industrial technologies. It used to be called like industrial software, like MES, cloud-based software, SaaS. And recent years, we have software-defined controls and absolutely data-driven method. Nowadays, AI is everywhere. So that is our focus. That's about Subcon. And actually, Subcon is a group company. Apart from the control system side, we also have smart city business. We also have several startups under our main entity. So FreezoneX is one of the startup. We do open source software for industrial IoT. Definitely, we nowadays we embrace the concept of UNS, and we also embrace the concept of open source. So we are a party to open source software company dedicated in doing UNS stuff. Yeah, that's about our organization. And for me, I'm a fresh grad, kind of. I just graduated for 2 years, and background in finance. But I got a chance to shift my career to control systems, to industrial. So I got a chance to be one of the founding member of our international team. So I think I don't have much things to speak about myself, but that's about us.
Absolutely. Thank you so much for that wonderful breakdown. I'm really excited to, dig into some of the topics that you raised in your introduction there. So maybe before we get into kind of like the technical aspects of it, I want to get your sense on what you're seeing as kind of like the technological or operational or even macroeconomic pressures that are accelerating the push for digital transformation, particularly in the process industries.
Yeah, so I think because my career span is quite short, so I'm a newbie in this industry. Absolutely, for process industry, you see people with like 30 or 40 years experience in the field. So, but my point of view is that we've been through several different phases. Like, let's say from 2015 maybe to 2020, we kind of the process industry in general, like energy, oil and gas, and pharma, we're generally in a good shape. And we have good margin, we have good profit, and we're expanding, especially in the East, in China mainland, we're expanding a lot. So people are looking for kind of luxury goods that can make their life better. So by that time, digitalization is kind of a luxury thing. And I think everything changed when it hit 2020, like COVID. And all the way till like 2022 or 2023. I think during that phase, we see a downturn of the like the market, general growth of the digitalization market, because people are just getting more realistic, and so the industry is they're absolutely not in good shape, and the competition was sky high. So competition is very intense, and so people are trying to cut down the budget on this, and so a lot of not so realistic or not so practical vendors, they I don't think they even made it through this phase. So then from 2023 till now, I think, or 2022 till now, I think there are this is I would say this is actually the beginning phase of when we're talking about industrial digitalization, because we see a lot of like foundational technology are really mature at this phase. Let's say unified namespace. In the past, everybody knows about unified namespace, but we don't have a lot of vendors, a lot of developers really practicing on it. So we don't have a very detailed technical definition of it. But now we see a lot of real projects running live in the field. So yeah, and also we see a lot of, let's say, traditional AI, data-driven things. They're really controlling the closed loop, and we see a lot of absolutely a bursting needs for generative AI. So maybe that is not so practical for now, but it's another piece of the growth of this market. So we see digitalization is getting more. I think that there are more hope in this market landscape.
Oh yeah, absolutely. And I think kind of like my own experience also resonates a lot with the characterization that you have laid out for us here, because I also started educating the industry on Industry 4.0 digitalization concepts around about 2015, kind of like really early when this all kind of like started out. And back then, to your point, really not a lot of companies really worried about what that is. It kind of like seemed to a lot of people out there that is a nice to have, something that is really wasting our time. We really want to focus on what we're doing right now, and we've seen this change over the years up until, as you mentioned, again 2022, when we saw everything getting to really hyper speed, right? And really attributed to a lot of factors, including competition and things like that. So we could really say that we are now in an era of really what we call modern manufacturing in a way, right? And many plants still rely on traditional PLCs and TCS systems and things like that, which is something that you are in a way really trying to change, or rather define what the feature of control could be with the software defined control approach, as you mentioned. So in your view, what do you see as being kind of like the main limitations of these legacy architectures when it comes to this modern manufacturing operations?
Well, this is a tough one. If I name one main obstacle, I think that would be the traditional. Let's say, I don't say traditional. The control system now we have is just too reliable, and they're just too good, and the design is just too beautiful. So as a newbie in this industry, when I look into the history, like back into the 70s, people like really invent the PLC and DCS. Yeah, that was by that time that was a kind of a rapid change in people's mindset, and in basically those people really, like, within 5 years they launched PLC, DCS, and really shake the whole industry. So that's a quite, to me, that's a miracle. And you have to admit that the invention back in the days still works now, works very well. So I would say that's the main reason why people just don't change, because boring is the best thing in OT world. But one thing, if you look forward, is that history moves on, and we will reach some point when there is a very talented team gather up another kind of like new DCS or PLC, like next generation of the invention, and they launch it, and people say, "Whoa, this is a new thing, and this is so beautiful, and this is definitely better than the past one," and we're going to embrace it. So, but we just didn't, for the industrial world and control system world, we just didn't haven't reached the point of that iPhone moment, kind of. Yeah.
Oh, that's super interesting. So maybe kind of like explain to our audience here, to kind of like set the context here. When we talk about software-defined control, what do we actually mean? What is it?
For software-defined control, I think now we have a common ground, like common understanding. It is the control system and control logic is defined totally by software, and all the logics, like above I/O layer, all the logics and computes are done by software. So you can imagine that actually your PC can be a control system, because you can run software on your PC, and also a server can be your control system because you can run software and compute and do the control signals on server, and as well as like Raspberry Pi or any standard hardware. So it's really hardware independent, and all the control and compute logic are happening in the software containers. So I think that's the main character of the so-called software-defined control system. And yeah, so but for the I/O layer and for the layers above, I think not much things are changed, and I don't think there is a very clear understanding, a clear, let's say, a standard illustrating like how should we deal with that, with those things. But for the control logics, there's a clear definition saying that a software-defined control system is like the control logic is computed by software itself.
Okay, so it sounds to me like really software-defined control is about eliminating the PLC as the hardware that interfaces directly with I/O module, and connecting your I/O directly to your PC or your server. And could you kind of like elaborate to us what are the benefits of kind of like doing away with that PLC layer?
So I think the main benefit is you have the access to literally unlimited computing power. Although so far we don't know how to deal with those computing power, we don't have a good application, like killer app for that. But it's really a good thing. It's really a cool thing. Like for one of the project we've done, we replaced like more than 1,000 cabinets, like because they used to use DCS system, and they reached their end of the life cycle of that system, and they decided to use we call it universal control system. So we have two sets of cabinets, standard server, Dell server inside, replacing more than 1,000 cabinets. So that's very amazing. And the computing power within that two cabinets is like more than, I cannot calculate, but I would say at least 100 times higher than the old ones. Yeah, so I think that's the main thing. We have really cheap and unlimited computing power within our control layer. That's a super cool thing.
Yeah. So I mean, if you speak to industrial automation engineers or subject matter experts about this possibility of getting rid of the PLC, or adopting the software defined control, I mean, you always get the same kind of like pushback, things about reliability, right, and security. So as you may know, obviously, running control or any kind of software on Windows, even just the SCADA operating system, where you need to constantly deal with things like software updates on Windows, and viruses and things like that. So that's kind of like those big arguments. So what do you say to that?
It is I would say it is basically impossible to persuade your customer, especially when they're a few engineer, because most of their claim is correct. It's the vulnerability is there, but based on our like objective assessment, I would say the vulnerability is more critical in the traditional system. We in process industry specifically, we've seen several major cyber attack towards OT system. It happens in Middle East, in North America. We all know the events. So it's like huge scale cyber attack, like shutting down 10,000s of operator station, shutting down the whole plant. It's very dangerous. But imagine if you have your control layer software defined, you can better prevent this kind of things to happen. Basically, you have your modern architecture, modern operating system, and you can better configure it so you can eliminate more like useless ports. But you cannot do that kind of thing within a Windows machine. So yeah, especially within a like Windows XP or Windows 7 is still out there in the field. So I would say with a modern, especially software-defined infrastructure, your life going to be easier, especially when you're facing cyber attacks, the threat. So because modern software is just evolved, so they're better, they're more flexible for you to kind of config and prevent this kind of event.
Awesome stuff. Okay, so now as part of this, new philosophy of software-defined control, or what you call a universal, control system, SUPCON has developed a product called and I don't know, it's NYX or it's Nix. How do you actually Nix? Okay, so a product called Nix. Can you please walk us through, the Nix platform?
Yeah, so it's a project started from 2022. It's quite new actually. So during a kind of a board meeting, so all the management of our company was sitting together, brainstorming like what is going to be the next technology, like next gen technology for process industry, and within that meeting, so it was me who raised the idea of why don't we just do a software-defined control system. The ideas are already there, like Siemens and Beckhoff. They've been practicing and like kind of trying to invent the new control system for years. Especially Beckhoff, they've been doing this from the 70s. So it's not a new thing. I just raised it, but everybody kind of taking it seriously. So we started from 2022. We really put money and our best people on that project, and within 6 months, our people at the very beginning, because they're DCS engineers, they know I/O cards, they know the cabinets, they know the compute parts and dual redundancy, but they just don't really believe on the software things. So at the very beginning, the founding engineers, they don't really convinced, and they don't really have the confidence. But after like a 3 months period, we're kind of getting the feedback from them. They're saying, what, we can do this within 6 months. We can do this. We can do a prototype within 6 months. So I think the second half of 2022, we have the first prototype, and during the 2023, the whole year we've been kind of keep developing the prototype with Dell, with our own team, and finally within 2024, last year, we'll be able to launch it and put it in real plant. Now we have it in a petrochemical plant in China and all kinds of industries like fine chemical and bio plants and all kinds of industries, especially mission critical industries. So it's quite an amazing thing how fast we can do it, and how a small team can kind of put together everything and make it a product, and it's really working in industrial landscape, and it's quite reliable. So that was the journey.
Awesome. So I mean, the engine of the Nix platform is what you call the Nix OS, which is basically a cloud-based real-time operating system. Could you kind of like give us to make it all concrete for our viewers and listeners, sort of like an architecture of how the Nix platform based off of the Nix OS, how is it connected to like your field equipment and the connectivity that is established, kind of like to paint the whole picture of that whole architecture?
Sure, absolutely. So I'll start from the field side. We are one of the early adapter of Ethernet APL. That's a new protocol allowing you to give each of your instrument or field device a IP, and using that IP address to all the way communicate to your like control system layer and even layers above. So that technology basically enabled us to plug in the Ethernet cable from the field all the way to the control system. So that is one of the very important technology. So based on Ethernet APL, we replace kind of the upper layer of the field communication system. We replace the Ethernet copper cable with optic fiber, and finally we aggregate all the connections of the field to even a single pair of fiber. So it can be spread out through switches and gateways to thousands and hundreds of thousands of IOs. So that's the connectivity layer. So between the control system and the field, you will see even one single pair of optical fiber plugged into the server. So then we go to the basically the hardware, the compute layer. So the compute layer, we are using a standard Dell server cluster, three instances of Dell R700, 720. Yeah, so very standard thing, standard hardware, powerful, reliable. We basically co-developed it with Dell because we need to make sure their reliability within, maybe we put them into a critical environment condition, they can still survive, they can still up and running. And within the server, we work into the operating system layer. So we have our own flavored Linux system. So we kind of take some of the good stuff from the print RT and vanilla Linux, and we have our own thing to make everything hard real time, and all the tasks are physically kind of distributed to all the physical cores of the server, like CPUs. And then we now move to the container layer. So now we kind of encapsulate all the hardware and operating system into a Kubernetes cluster. But it's not vanilla Kubernetes. We do some kind of enhancement of the real-time performance and reliability of it. But it's still like kind of vanilla Kubernetes compatible. So you can still use Helm, still use a lot of Kubernetes features on it. And the most amazing thing is you can then install your own containers on this layer, say be a Python script, or let's say a virtual controller based on a machine learning algorithm. It can seamlessly communicate with your controllers. The latency can be down to millisecond level without any OPC, DA, or UA, or any kind of information bridges. So this is the most beautiful thing. So we have a lot of developers in-house, students, and our ISI vendors. They can develop their own program, try it out, and put it on the controller. Then their program going to be as a container format and communicating with the controller directly. So that's the most amazing thing. Then this is the whole architecture of our universal control system, the Nix.
I mean, that's super interesting, to mention that you're basically, getting rid of a whole lot of, communication protocols in the middle, like your OPC UA, communicating directly with the field device. And also something that I find interesting and would like to sort of like get your sense on is, does this also mean kind of like, doing away with traditional PLC programming languages like your ladder logic, your structured, language, and really going to higher level languages like Python?
We are not 100% there yet, but we can now translate Python into 6.1 for 9.9, yeah, and into our own. In DCS world, things can be a little bit different. So everybody have their own configuration UI. They have their own kind of flavored control system programming language. But we're kind of trying to translate the traditional, translate the high level programming language like Python or JavaScript into the traditional control system programming language. But definitely the next step would be maybe using general high level programming language to directly control the controllers, since they're all softwares.
Oh yeah. I mean, ultimately, this is all software. I remember. So I've got a background in embedded systems design. So when I first started out, learning how to program microcontrollers, we're using assembly, logic with this professor who taught us how to use assembly. And when I came across some tools that allow you to build that same code using C, it was for me really transformational. But it was interesting that there's a whole lot of people who still wanted to hold on to the idea that no, you don't need to go to C, because you lose a lot of power if you sort of adopt C and not use assembly language, which obviously there's some truth to that. But as far as productivity and really bringing in a whole lot of capable workforce, it's not comparable even, right? So yeah, really interesting. So another issue that I want to kind of talk to you about is the artificial intelligence. So clearly AI is also really a cornerstone of this evolution of software defined control. So Subcon has an AI powered control engine within their platform. Could you talk to us about what kind of functionality does that bring into the picture?
Yeah, sure. So because we are kind of originated from process industry, so in process control, people have started doing like artificial intelligence for many decades ago, and neural net was there like 20 years before, even 30 years before, in the controller level. So now the difference thing now we are offering is we are using like completely black box method AI driven controller in the closed loop. So a comparable peer would be a traditional, let's say, MPC controller. In process industry, we have a commercial name is APC, Advanced Process Control, but in the backend it's actually Model Predictive Control. It's basically connect multiple I/O and let them to kind of work together. But it's kind of very complex because you're really dealing with process. Yeah, so time lag, a lot of issues can happen. So MPC, or in our world APC, is not always an easy thing to adapt, but it's very important. Like for a lot of refinery or chemical company, in their field, if they want to achieve higher efficiency, like APC is kind of a must-have for, especially for their complex loops. But again, there are limitations. It's very hard to adapt because it takes up to even half a year, even a whole year, for the engineers from the vendor side and the client side to sit together to understand the loop and to model it up with a first principle tools, basically it's from control theory. And then once the condition changed, let's say there's a heavy rain or weather changed, the whole thing needs to be readjusted. So that's another downside. So actually, once people from the process industry, once an end user purchased APC solution, that doesn't mean they're using it forever. In a lot of cases, they invest a lot of money on APC, but actually it turns out getting no value of it because the operators and the control experts, they just don't want to use it. It's too complicated and it's too hard to adapt. So our approach now is we we basically provide you for the, especially for the hard, complex loops, is sometimes it is even impossible to model. That means you can never put APC on it, but we can introduce AI. We can introduce basically time series model to kind of reverse engineer the whole first principle logics, but we don't know the exact functions behind this. But we got the result. Then we compare the result with the testing data sets. Once we see a good score, like kind of a good regression of our own model, then we can let our own model to provide predicted value of that loop. Then we can use that predicted value to kind of inform the control loop how to adjust. So we call it the time series pre-trained transformer. It's a new approach, especially for complex control loops. In the past, it's hard to optimize and even impossible to optimize, but now with our time series model, is a possible thing, and you can get good result. And another thing is, because it's time series model, it can basically predict the future value of one specific tag or a whole loop. So you can imagine you can do a lot of things with this predicted value. So this thing from our side is called time series pre-trained transformer, TPT. This is our main AI offering.
Awesome. So, I mean, there's, I want to take a bit of a tangent also here on, because I noticed you also, use reinforcement learning in control environments, and I want to get your sense on, because I don't think, a lot of people really understand, the impact of really bringing reinforcement learning into the control environment, because we're in an industry where things remain fixed for like 50 years, right? So someone just controls something. This is how it works for 50 years. You don't touch it. Maybe you may make a few tweaks in the code and things like that. But with reinforcement learning, you're kind of like really, telling me that you're sort of like learning what your system, how better you could actually really optimize your system in real time. And then could you kind of like, briefly explain to us what is the impact really of reinforcement learning?
So RIO is actually another approach, but it's not 100% productized. So we're not, by far, we're not commercializing it. We're still piloting this technology with our customer and trying to develop it further. So it's a totally different methodology comparing with control series, definitely, or time series method. So within time series or our TPT model, it take in the real-time tag value and predict the future, and using that future value to do the optimization. And with reinforcement learning, it's totally different. We have an environment, basically our plant or factory, you can interact with. We have an agent in our real life that is human operator, control experts, and we have something called reward functions. So in real life, it would be, I want to maximize the productivity, and we want to achieve absolutely zero downtime. That would be the reward function. And they kind of interact. The agent kind of take a movement, and then the environment going to receive that movement and do some change, because real world is physics engine, and then it kind of renew the state, and then you can get the state into the reward function. You got your reward. If the reward is kind of something below zero, then your agent gonna know, okay, this is a bad movement, I'm not gonna doing it anymore. If it's a good move, you got a reward beyond zero or very big value, then you can keep doing it. And this is the methodology of reinforcement learning as differences. So in our approach, as you can imagine, using reinforcement learning can really make your plant or factory autonomous. Ultimately, I would say, by far, where the whole industry is kind of far away from there. But ultimately, reinforcement learning is just like human being, a human operator. It take control of your HMIs, even control all the control systems, and they do something, and they keep observing the situation, and they kind of adapt it. yeah, so this is going to be a really game-changing thing for industrial world. So reinforcement learning is, it's just like human.
Awesome stuff. Yeah, so I mean, as you may know, modernization is always challenging, especially in brownfield environments. So, for manufacturers who, may want to adopt this unified or rather universal control system approach, what are some of the practical strategies for transitioning from, traditional DCS to UCS?
So our recommendation is, I would say, especially for process industry and users, the first thing you want to make sure is once you're introducing a new technology, it won't mess up your current production operation. So we now have a standard called OPAS, and it's from OPAF. So I think now is the dominating standard for software-defined control system, especially for process industry. So a lot of vendors, the SDA players, they're all there, including us. So once you go to the standard, and you're going to see all the architecture. How do you migrate from a brownfield to a new way of kind of a mixing control system architecture, or maybe you kind of renovate your whole plant, or you have a greenfield. They got roadmaps for you to reference. So this is the first thing. And another beautiful thing is OPAS. Now they have certifications. So once you kind of issuing your RFP, make sure you have the standard requirements in it, so you can have better coverage. But I would say this is not a kind of a magic cure, the standard, because it's still a young one. We're still trying to iterate it. So another call for action is, because the industry is moving on, we all know control system not going to stay there forever. So once you just take the leap, maybe it's a small POC of one of your unit or equipment. Maybe it's a new plant. Just take a chance to try it out. It's not that hard, especially for greenfield. If your asset is really mission critical, you're afraid of risks, maybe just get a POC, narrow down the scope and try it out. Then you got confidence and expand it. So start small, move fast, and most important thing is to take the leap of faith.
Great stuff. Yeah, so I realize we're fast, running out of time, and so I would like to jump to the topic of the unified namespace architecture, which is a topic that I evangelize a lot about, and also something that you have invested heavily in the form of SUPOS, which is an open source unified namespace platform. So, first of all, before we kind of break down the platform, I would like to find out from you, why do you believe the unified namespace is such a critical, enabler for digital transformation?
Yes, because it's just like the software-defined control system, it's a modern architecture. You don't have OPCD, you don't have OPCDA to worry about. You don't have very complex, like a lot of historical version of standards to worry about. It's a completely modern thing, and it's event-driven. It is pops up, and you got a lot of cool stuff for industry there in the unified namespace architecture. So yeah, I think because the first thing is it is modern, it's very important, and the other thing is the design pattern of unified namespace is it's very suitable for industrial usage.
Awesome. So can you maybe unpack for us the SUPOS platform, which is your implementation of the unified namespace?
Yeah. So SUPOS platform, first of all, is open source software, and nowadays, a lot of open source software consist of other different pieces of open source softwares. For example, Superbase. They're kind of a combination of dozen of different open source softwares, and then encapsulate them and let them to work together. So in unified namespace, we have MQTT broker, we have like kind of flow-based programming languages or DAG drawers to chain the backend, to chain the logic. And we have historical layer to store the value from MQTT broker. So when you look into unified namespace, you see a lot of different components, and those components kind of pointing to different out-of-the-box universal kind of open source software, because a lot of people are already using those software in the industrial world. So our idea is, let's don't reinvent the wheel, and let's bundle them together and let them to work together. And we are definitely not the first one doing this. UMH, they did an excellent, great job, and I would say they're the first one who are really pushing this idea to reality. Yeah, and now we're doing the similar thing.
Awesome. Yeah, so I mean, another big topic that has come up in the past couple of years, or rather past years, since the advent of LLMs, is the rise of AI agents for industrial systems. And so a lot of people have started thinking about how they could bring together AI agents and the unified namespace. And as part of your SUPOS platform, you have what is called the factory agent, which in a way integrates LLM intelligence with the unified namespace. Can you kind of like unpack for us how that integration works?
Yeah, so it's actually a Node-RED community node written by us. It's called Factory Agent. It consists of several nodes for you to communicate with the LLM, feeding them MQTT data. They can kind of bundle it and pack it with the user-defined prompts and send it to LLM. And there's a state machine behind it to make sure there are no message conjunctions. And besides that, we have several different nodes for you to define the so-called action and tools and prompts. So because now agent, especially LLM agent, is not a mystery thing. Everybody knows how it works. And you program the agents using natural language, right? So our work is basically give you out-of-the-box nodes, help you to type in your prompts using natural languages to define like kind of what is the action that LLM can take, even connecting or calling an OT asset or OT controller. So we're kind of bridging the last mile. Yeah, this is what we do.
Awesome. So yeah, I mean, to kind of like really bring everything together, could you talk to us about some real world examples? I think you mentioned one use case where some company has successfully deployed this idea of a software defined control. Could you kind of like walk us through that?
Yeah, sure. So actually we have now more than 50 major process industry customers in mainland China now adapting our UCS in their real productions, not POCs, it's real productions. I will mention the biggest one. They have in total, it is a greenfield project. It's a new refinery in East China. I think it's by far the largest refinery, like single base refinery in the planet, and they have three critical units. I cannot mention the exact process, but it's very important unit equipment for a refinery. Think of the distiller connected to our control system. It's still under commissioning process. But yeah, so this is I would say this is a very bold move, and their technical team really looked into our technology. Actually, they even skipped us. They look into the really technical detail. They look into also all those operating system control layers and connectivity layers and decided to adapt this. So I would say this is a proof that based on current like human technology development, the software-defined control system is not a toy anymore. It really can be adapted by mission-critical industries. So I think that is the proof.
Yeah, I mean, just also to paint a clearer picture for our audience here, I'd like to get your sense on what has this helped them achieve that is not possible for other sort of, for example, a refinery that is not using software-defined control.
Yeah, so an interesting thing is they plan to build a distributed control room, like a set of 5 control rooms in total, scattered out within their manufacturing base. But now they decided to cancel 2 or 3 of them because they no longer need those distributed DCS out there. They can plug in everything and wire them into a standalone control room, centralized control room. And you can still distribute the software-defined control system to different places to make further redundancy and reliability. But you just don't need to build those space for the DCS cabinets, because we're talking about thousands of cabinets. It really requires a huge space. And I think people from the refinery business will know that building a kind of explosion-proof space, a room itself, is super expensive and time costly. And I think this really helps them a lot. And another thing is we are really exploring and testing a lot of new technologies like AI-based controllers and TPT in the loop. So basically the software-based control system enabled this possibility, but now it's not totally commercialized and a lot of people are using AI in a closed loop, but without a software-defined infrastructure, it's very possible. Even you have the good model, you have the good AI, but you just have no place to deploy them. You still got a lot of like kind of boundaries between your information layers. So yeah, software-defined control system really enable this possibility.
Awesome stuff. Yeah, so I mean, to wrap up, Messi, what advice would you give to manufacturing and digital leaders who are planning their roadmap towards, software-defined control, AI-enabled operations, and all the advanced technologies? What are the most critical steps or things they need to start to think about right now?
Yeah, I think from a vendor point of view, our suggestion is first look into open technology. So if a technology or product cannot reveal their underlying components in technical language, it is just not so advanced. They're not, maybe the vendor themselves, they're not so confident. So look into open technology. It's not only can help you get rid of the vendor lock-in issue, also kind of ensure you're getting the best or state-of-the-art technology in the world. And the other thing is really, I suggest everybody to take kind of a leap of faith, because in the past 10 years, in the last decade, we can say that software-defined control system is still a concept or is still under testing. But now a lot of major vendors, and also including us from DCS or PLC, we have out-of-the-box products, and we have like thousands of use cases like across the world. So it's a tested technology, and it's going to be the future, and the future is now.
Awesome stuff. Thanks again, Messi, for taking the time to join us here today on the show. I really appreciate it. We're going to provide links to all the different products and tools that we mentioned in this podcast. Again, thank you so much for taking the time to join us. Really appreciate it.
Thank you very much. Thank you. Good night.